Hello AP Physics students, this is Mr. Ellis with another video on vectors this time. So this is the same material as we went over in class in the lecture, and I'm actually starting on the second page of the notes because this is really the stuff that I think people have trouble with and that I wanted to go over one more time and just get started. So the key skill here is what you see on this screen, how to add two-dimensional vectors using their components. And there's a lot going on. So let's just take this one step at a time. Every vector has a direction. If you describe the vector in terms of its magnitude and direction, that's great. That's a complete description of the vector, but it's not really helpful in adding the vectors mathematically. So what we need to do is split them into their components. This is going to help us add up the vectors with the least amount of effort. So every vector can be broken up into basically its height and its sort of length, like along the x-axis, height along the y-axis. These two component vectors added together equal the original vector. In order to find these, we have to use trig. So using the angle, we can decide, all right, which trig function do we need? If we know the hypotenuse, right, and we want the adjacent side, we know we're going to have to use the one with A and H. That's right? Wait, so toa, right? Adjacent hypotenuse. So yeah, I always get that messed up. But this is going to be how we find the adjacent side or the x component. You just do a little algebra, and it's a cosine theta. Similarly, the y component, we want the opposite side. It's going to be the sine, a sine theta. That's going to work in most situations, but you have to be careful. In this case, with the angle measured relative to the y-axis, it's not the same. So how do we do this in 2 dimensions with a full problem? So first, we got to follow the steps. Step 1, you draw it, right? And we just did that. So that's the first part, which I think most of you guys can definitely do. Step 2, you got to resolve them into their components. So use trig, right? Following what we learned before, right? It's like a cosine theta, a sine theta. That takes care of A. B cosine theta, B sine theta takes care of B. And if we write these in rectangular notation, they come out like that, and you can do the work up here to figure out, what exactly it is in decimal form. All right, step 3. So this time we can add things that are in the same axis. So, things just add or subtract when they're along the same direction. In this case, the A and B x components subtract. C has no x component, so that tells us the resultant's x component. In terms of the y-axis, C has a y component. That's the opposite direction of the other two, so it's going to subtract, leaving us with 0.92. In rectangular notation, we can write the resultant, but we're not done because we still need to find what that resultant vector really is, like what's its magnitude and direction. So Pythagorean theorem gives us the magnitude. For the direction, you got to use trig again. And this time it's an inverse trig function to get the angle. And that's how you follow the steps to get the resultant vector. Thanks for watching.